Hello everybody. In this video we will learn about logarithmic functions. We will learn how to evaluate logarithmic functions as well as we will learn about the relationship between logarithmic function and exponential function. So every exponential function, that is f of x is equal to a power x with a greater than 0 and a not equal to 1, is one-to-one function. So that is, you can see that by horizontal test. That is, if you know that an exponential function, typically it looks like it looks like this, right? So it looks somewhat like this, or it looks like this, correct? So if you perform the horizontal line test, so you can see that the blue lines touch the graph only at one point, therefore it is a one-to-one function, and therefore it implies that it has an inverse, right? So every exponential function, so every one-to-one function will have an inverse. So as this function is one-to-one, so it has an inverse. So that inverse is nothing but f inverse. This is nothing but the logarithmic function. Logarithmic function with base a. With base a, and it is denoted as log base a. Okay, log subscript a. And if we recall from section 2.8, we know that f inverse is defined by f inverse of x is equal to y. That implies f of y is equal to x, right? F of y is equal to x. So this leads to the definition of logarithmic function, that is, let a be a positive number with a not equal to 1, then the logarithmic function with base a, the logarithmic function with base a denoted by log subscript a is defined by log a x is y. So that if and only if inverse is a to the power of y is equal to x. So that means the log x to base a is the exponent to which base a must be raised to give x. So this is nothing but the exponent to which base a must be raised to give x. Okay, when we use the definition of logarithms, we switch back and forth between logarithmic form, that is log a to base x is equal to y, and the exponential form a power y is equal to x. So we have to be very careful and notice about the base. So we have to see that the base for the logarithmic function as well as the exponential function is the same. So if this is the logarithmic form, log form, and this is the exponential form, right? So the exponential form is a power y is equal to x. So here the base is a as well as the base is the same in both the cases, and the exponent is y. Even here the exponent is y. Okay, so now for example, the logarithmic and exponential forms are equivalent equations. If one is true, then the other will also be true. So we can switch from one form to the other. For example, if we take log 10 of 1 lakh 1 lakh. So this would be nothing but, so what is this? Base 10, and this is playing the role of x, correct? This is nothing but, if this is 5, yeah, so you have to raise, this is the logarithmic form, this is the log form, and the exponential form would be 5 power 10 is equal to 1 lakh. Okay, so yeah, the same thing applies to log to base 2 to 8. If this is 3, so 2 power 3 is 8. So you know what this value is, right? So this makes sense. Yeah, you can see the definition being applied in this case, and you can see it is true also, like, because 2 cube is 8. So it is important to understand that log x to base a is an exponent. That is, for example, the numbers in the right hand column of the table here, so are the logarithms with base, different bases, like 10 in the first case and base 2 in the second case. So this is the case for all bases. Okay, so if we have to evaluating logarithms, how do we do that? If we have to evaluate, say, log 16 4, so this is equal to to what power, if you raise 16, will you get 4? That is, square root of 16 is 4. So that power, the exponent will be the value here. Okay, so it is 1 over 2, because 16 to the power of 1 over 2 is 4. So that is how you evaluate the logarithmic functions using the exponential functions. So to do, let me do an exercise problem for you. Say problem number 10. Okay, problem number 10 in your book. So you are asked to evaluate log 5 of 1 over 5. So yeah, express the equation in the exponential form. So you have to express this equation in the exponential form. So what is it? This is the base, and this is the number, and this is the exponent, right? So 5 to the power of -1 is 1 over 5. This is true. We know that this is true. We have learned this in while we were learning exponents. So the exponential form is this. That is 5 to the power of -1 is equal to 1 over 5. So if I have to, yeah, there is a second part of the equation as well. So now B, that is log 64 4 is equal to 3 to base 4. Yeah, so this is 4 and this is the exponent, right? So 4 cube is equal to 64. This is the exponential form. Base and exponent. So exponential form. Yeah, exponential form is right, and we know that by definition this would be the exponential form of the logarithm of the given logarithmic form. So if you have to do the vice versa, so I will do problem number 18 for you. Say 6 square is equal to 36. So this is the base and this is an exponent, correct? So we have log to the base 6 of 36 is 2. Okay, this is the logarithmic form. I'll do another problem, that is a B part of the same problem. 10 inverse is equal to 1 over 10. So what is the base? This is the base, and this is the exponent. So you just have to identify the base and the exponent and write it according to the logarithmic form that is given in the definition. So log to the base 10 of this number, that is 1 over 10 is -1. Okay, so this is the logarithmic form. So this is how you evaluate logarithmic functions. Next we will learn about properties of logarithms. Properties of logarithms. So the first one, log to the base a of 1 is 0. Second, log a of a is equal to 1. Third, log a of a power x is equal to x. 4, fourth one, a to the power of log a power x is equal to x. So how do we know all these are true? If we express the first one as a exponential form, so this will be the base and this will be the exponent, right? So we know that anything to the power of 0 is 1. So this makes sense. If we prove this is definitely true by the definition, correct? And the second one, so this is the base and this is the exponent. So raise a to the power of 1, so it will be a, and that also is making sense. And a is the base and exponent is x. A power x is a power x itself. So that's why you have the logarithmic or log base a to the log of a to the power of x to the base a is equal to x itself. And what happens here? Here you know that a power something, you have this in the exponential form. So a to the power of log x is equal to x. So if you have to express this in the exponential form, so this is the base and logarithmic form, and this is the exponential form, right? So log of you get that to be log of base is a, okay, log a, and of exponent, yeah. So the exponent should be written here, okay. So log of ax is nothing but log of ax, correct, the power. So LHS is equal to RHS. So this makes sense. All the properties make sense. So to repeat again, these properties are really essential, and we use them like forever. Whenever, even in higher level of mathematics, we use this. So it is better you know all these properties very well. Okay, so let us apply properties and solve some exercises. If I have to solve problem number 26 for you. So problem number 26 says that evaluate the expression. Say log to the base 3 of 3 power 7. So this is you can clearly see this is of the form property number 3. So property number 3 implies log of a power x to the base a is x itself. So applying that, we get log 3 to the power of 3 power 7. Here 3 is a is 3 and x is 7. So this will be equal to 7. Okay, this was A of the problem. And if I have to solve B, okay, log 64 to 64, base 64 itself, that is log A to A. This is property number 2. So applying property number 2, that is log of A to base A is 1. So log of 64 I'm sorry 64 to the base 64 is 1. Okay, so we have C, property number C, which says that log 125 to base 5 is, okay, you have to evaluate this. So this is how does this look like? So 125 is nothing but 5 cube, correct? So you can rewrite this as log 5 of 5 cube. So now applying property number 3 again, that is log of a power x to the base a will be x itself. Sorry. Yeah. So that implies log 5 log to the base 5 of 5 cube will be 3, applying the property. Okay, so now it's time for your quiz 4.3.1. you have to do problem number 12 in the book and problem number 20 and problem number 34. Okay, I will end this video here. In the next video we will learn about graphing logarithmic functions.